Hi students, let's look at this question here, which is on application of differentiation taken from one of the past year. We do not know which year, but it's paper 2 question 5. So if you know which year, please do let us know. So show algebraically that the derivative of this function is never negative. I think we can just let y equals to ln 1 plus x minus 2x over x plus 2. All right, then it's never negative. So I think what I will do is I'll just do a long division here because I want to avoid doing quotient rule. If you want to do quotient rule, you can do it as well. So this is minus 2. This y equals to ln 1 plus x minus 2 minus 2 over x plus 2. Alright. Then we just expand this. It'll be ln 1 plus x plus 2 over x plus 2 minus 2y. So then dy dx we 1 over 1 plus x minus of 2 x plus 2 square. Okay, great. Now this doesn't seem like it's always positive, but or rather never negative. What we could do is actually just plot the graph out using our GC and just examine. Sorry, I made a mistake there. Careless one. I'll just fix it. So this will be 4 actually. So this is minus 4. This is 4. So what we do is now I'm going to plot the graph. So I could see that because we need the derivative graph, so it's 1 plus x, and after which I'm gonna plot the actual graph first. Here meaning to say the gradient, right? The gradient will always be positive. So we graph it out. You'll see there's actually this juncture here, which is the gradient is always positive. So this right here, I'm gonna just put it here. The zoom box. I just want to see how it looks like. Okay, there you go. So it looks something like that. Great. So you can clearly see there's somewhat an asymptote there, right? So it shouldn't be an issue because you know that for ln 1 plus x, 1 plus x has to be bigger than 0. That would be the valid range domain for ln 1 plus x to be valid, right? So it looks difficult here. What we can do is actually just combine them as a single fraction, and this will be 1 plus x, and this is x plus 2 square, x plus 2 square minus 4, x plus 1. Then after which what we do is x squared plus 4x plus 4 minus 4x minus 4 is x plus 1, x plus 2 square. That will give us x squared over x plus 1, x plus 2 square, which means will translate to x plus 1 and x over x plus 2 square. Okay, do you see that? So this is definitely always positive because of the square there. This x plus 1, like we already established, that it has to be. So since ln 1 plus x is we imply that since 1 plus x is bigger than 0 for and x over x plus 2 square is actually at least 0, because it could be 0, right? But it will never be 0. Thus these both combined together will be at least 0. Okay, so once this is done, what we could do is that this will imply that dy dx is at least 0. So shown. Okay, thus derivative of function ln 1 plus x minus 2x x plus 2 is never negative. You can actually put the graph out, you will see that it's never negative. All right, so that's done. So hence show that this bigger than 0 when x is bigger than, show that ln x when x is at least 0. Okay, let's try and see. So for part 2, we know that x plus 1 x plus 2 square 0. Taking the wrong function here, actually should just look at this one here. It's never negative. So this case here, ln 1 plus x minus 2x. Okay, I took the wrong equation again, so I think I'll just take the inequality. But the idea is essentially how do we use the previous result to actually show this. Okay, so let's try and understand this part here. So what we're going to do is I'm just going to start off by writing this out. This graph here, 2x over x plus 2. Then what we need to do is just ln 1 plus x, and of which just minus 2x. X plus 2 bigger than 0. Okay, so this over here is what our y is, right? This is our y. So essentially what we want to do is actually finding y, what is y, when is y bigger than 0, but we know for a fact that because the graph that we're looking at, or rather the previous result tells us that it's an increasing function. So in other words, what we need here is that, okay, we know that this is x equals to minus 1, but this is an increasing function, right? So the solution that we want to solve is actually here to here. This is where y is bigger, at least y equals 0. Okay, so we need to, so essentially if it's always increasing, what you need to do is actually just find this value here. So that's what you're gonna say. So you say that since is an increasing function from 1 increasing function, okay, y bigger than 0, we need to find a y-intercept lah. Oh, so the function is bigger than 0, at least 0, when it cuts the x-axis. Okay, so it shows that it always cuts above there. So once this is done, you just need to show that also, hence when y goes 0, we know ln 1 plus x minus 2x, x plus 2 equals 0. This would be, when you solve this is x equals to 0, I believe, because you by observation or by GC lah. Okay, this is 0, but by observation lah. So this would actually, this intercept here is 0. Okay, so hence ln 1 plus x minus 2x x plus 2 at least 0 is at least 0 for when x is bigger than 0. So that's how you use the previous result to actually show the second part. Okay, so if you have any questions or comments at all, please do let us know, and I'll see you in the next question then.